electric experiment. So alpha particles leave that box, the wooden box that the radium was in. There's a small hole. Alpha exits, makes its way to the gold foil. Detectors allowed to swing around in almost a 360 swing. The observation from this experiment was that most of the alpha particles went straight through. So as 0 degrees is the angle where it's the straight through position, we're expecting the maximum number of particles here at 0 degrees. That indicates B, C and D. We had some particles deflect at angles between 0 and 90 either side. So which one shows some? This one shows some between 0 and 90, this one shows some between 0 and 90, and this one shows some between 0 and 90 as well. But what we have to look at is comparisons in the amount. So here we see there's a big drop off. Here we see the gradual drop off. Here we see the drop off and then an increase. So the third observation was that a few of the alpha particles, 1 in 8,000, deflected back the same way, so between 90 and 170, so very few compared to all the particles that are passing through. So which one shows very few between 0 and 90 and 170? That doesn't make any sense because that says the number starts to increase, which is not correct. 1 in 8,000, that's showing more or less a very similar number to the ones that are 0 degrees, so we can discount A and B. C would be more plausible because the drop off is rapid, because at 90 degrees we'd see almost just above 0, so that would reflect 1 in 8,000, I would say, between 90 and 170. And some particles deflected between 0 and 90, and that is a better representation of the number of particles based on the experiment. This shows a gradual change. It shows us there's a very large number of particles detected at 90 to 170, and that there at 90 is almost half that going straight through, so that doesn't make any sense. So the one that makes the most sense is C.